Welcome, everyone, to techdaily.ai. Get ready for a truly insightful deep dive today, specifically tailored for you. This deep dive is proudly sponsored by StoneFly. They're your trusted solution provider and advisor in, well, pretty much everything: enterprise data, storage, backup disaster recovery, hyperconverged VMware, Hyper-V, Proxmox clusters, AI servers, SA365, even turnkey security appliances, public and private cloud solutions. You can check out stonefly.com for more information. Okay, now let's unpack this. You've sent us a really fascinating stack of material all about what's ahead in the world of technology, looking towards 2025, right? So our mission today really is to cut through all the noise, pinpoint the absolute most important emerging trends, and help you understand not just what they are, but maybe more importantly, why they actually matter for your future.
Yeah.
Think of it as like your shortcut to being genuinely well-informed without feeling completely overwhelmed by all the data flying around.
And what's truly fascinating here is just the sheer speed, the velocity at which this whole landscape is shifting. Technology isn't just, evolving step by step anymore.
Wow, it feels like heaps.
Exactly. It's fundamentally reshaping entire industries, business models, even the very nature of job roles.
Yeah.
So this deep dive, hopefully, will offer a clearer roadmap to understanding those big transformations and identifying the crucial skills you'll need to not just navigate, but really thrive.
Absolutely. We're talking about everything from the next big jumps in artificial intelligence to how your daily life, maybe your commute, how you learn might fundamentally change. It's about spotting those aha moments,
Yeah.
making complex stuff click. So if we're going to dive into the tech frontier, where else do we start but with the thing that's just dominating every conversation, generative AI? Going through the material, it just kept jumping out. For someone who only has a sort of surface level idea, what's the one thing they really need to grasp about why it's so impactful?
Well, what's truly transformative about generative AI isn't just its ability to create, like, human-like content, text, images, sure, even complex simulations.
Right.
It's how it's revolutionizing creative problem solving and hyper-personalized customer engagement at a scale we've never seen before. Think about companies using it to, say, design entirely new products based on user feedback almost in real time.
Wow.
Or generating complex software code much faster than human developers could. It's moving beyond just content creation. It's becoming a genuine innovation engine.
And here's where it gets really interesting for you listening. One surprising nugget from the material we looked at indicates that 71% of leaders are more likely to hire a less experienced candidate with strong generative AI skills than someone more experienced without them.
Yeah.
That statistic just jumps off the page, doesn't it? What does that tell us about the immediate demand?
It speaks volumes, really. It shows how quickly the market is prioritizing these new capabilities over just, traditional years of experience alone. It suggests adaptability. The ability to leverage these new tools is becoming almost non-negotiable. For a lot of organizations, the capacity to innovate rapidly using Gen AI is now seen as a critical competitive advantage. And they're willing to invest in talent that can deliver that, even if, their resume isn't decade long. It's not just a trend. It feels like a fundamental shift in what counts as valuable expertise.
That's a huge takeaway. Okay, so from something that's already impacting daily workflows, let's pivot. Let's go to a realm that, frankly, still feels a bit like science fiction, but is rapidly becoming real: quantum computing. We hear the buzzwords, but how exactly does it work? It's magic. What kind of problems is it uniquely set up to solve?
That's a great question, because it does sound like sci-fi. At its core, quantum computing leverages these, mind-bending principles of quantum mechanics. It uses things called qubits.
Qubits, right.
Yeah, and these qubits can exist in multiple states at the same time. This allows quantum computers to process information exponentially faster. But, and this is key for very specific, incredibly complex tasks that even the most powerful traditional supercomputers today just can't handle them.
So we're not just talking about fast, like my new laptop is faster than my old one. It's a different kind of speed.
Exactly. It's a completely different way of computing. Imagine simulating every possible chemical interaction for a new drug compound in minutes. That could collapse decades of traditional lab work.
Wow.
Or, maybe more concerningly, rendering current encryption methods totally obsolete overnight, which would demand entirely new security approaches.
Okay.
Now, it's still in its early stages for widespread commercial use, but its potential to revolutionize areas like cryptography, drug discovery, material science, complex optimization. It's immense. It's not about replacing your laptop. It's about solving problems that we previously thought were just intractable.
Speaking of kind of mimicking complex systems like the brain, what about neuromorphic computing? That sounds incredibly advanced, taking inspiration straight from biology.
It is, yeah.
Yeah.
Neuromorphic computing is all about designing computer chips and systems that literally mimic the human brain's neural structures and how it processes information.
Huh.
The goal is to achieve incredible energy efficiency and computational power,
Hmm.
especially for tasks our brains are naturally good at. Things like pattern recognition, sensory data processing, real-time learning from messy, unstructured data.
Okay.
Think about applications in edge AI devices, AI running directly on your gadget, not in the cloud, or advanced robotics, or maybe even more nuanced AI systems that can learn and adapt on the fly without needing massive data centers. It's trying to break free from that traditional step-by-step computer architecture and move towards more brain-like parallel processing.
So we've explored this raw power, right? AI's problem solving, quantum's potential. But what's the glue? What holds all this together and lets these technologies really transform things? That has to be connectivity.
Absolutely.
Let's unpack 5G. We hear about it constantly, but what's its real, tangible impact looking towards 2025?
Yeah, 5G expansion is absolutely crucial, and its impact goes way beyond just faster downloads on your phone, though that's nice too.
Yeah.
It promises significantly faster speeds, yes, potentially up to 10 times faster than 4G, peak rates around 20 gigabits per second, which is staggering.
Yeah.
But just as important, maybe more so, is the wider coverage, and critically, its incredibly low latency.
Ah, the latency, that's the delay.
Exactly. That minimal delay, that high-speed, low-latency connection, that's what's truly enabling the widespread adoption of technologies like the Internet of Things or
Yeah.
fully autonomous vehicles. It's what allows for that real-time communication between millions, even billions of devices,
Got it.
and processing huge amounts of data with almost no lag. It really supports a whole new wave of innovation, everything from smart cities managing traffic flow to potentially remote surgery.
And connecting right into that ubiquitous connectivity, we have these immersive worlds, augmented reality, virtual reality, this broader thing called extended reality, sometimes called AR and VR 2.0. What's the key difference between AR and VR, and where are they heading in terms of, practical uses?
That's a great distinction to make. So augmented reality, AR, overlays digital information directly onto your view of the real world.
Okay, like Pokemon Go or those furniture apps.
Exactly. Or think of a mechanic seeing repair instructions overlaid right onto an engine through spectral glasses. It's transforming sectors like retail, real estate, education, field service.
Hmm.
Virtual reality 2.0, on the other hand, fully immerses you in a completely simulated environment. We're seeing big leaps now in display quality, wider fields of view, more comfortable user-friendly headsets. This makes for much more realistic experiences, obviously for gaming, but crucially, also for specialized training and even therapy.
Okay, so what does this mean specifically for things like, say, professional training or simulations?
Well, that brings us neatly to extended reality, or XR. That's the umbrella term covering VR, AR, and also mixed reality, which blends the two. In professional settings, XR is providing these amazing, risk-free, hands-on training simulations.
Risk-free being the key.
Absolutely. In critical industries like healthcare, aviation, manufacturing, imagine medical students practicing complex surgeries with zero risk to actual patients.
Yeah.
Or pilots running through emergency scenarios in a totally realistic virtual cockpit. This tech is proving to significantly improve learning outcomes, boost engagement, and importantly, reduce training costs by replicating real-life situations safely in a virtual space. It's a real game changer for developing skills.
We've talked about the incredible power, the connections enabling it all. But how are these technologies actually showing up in our daily lives, transforming cities, industries, even how we keep ourselves safe? Let's talk about the Internet of Things, especially in smart cities. How's that playing out as we approach 2025?
Yeah, IoT in smart cities is becoming huge. It involves integrating countless sensors and devices that collect data to manage assets, resources, services much more efficiently.
Like what specifically?
Well, think about traffic lights that adapt in real time to optimize traffic flow and reduce congestion based on actual conditions. Smart grids that dynamically balance energy use across the city, or connected systems that enhance public safety, maybe optimizing emergency response routes.
Okay.
It's really helping cities manage their inherent complexity and significantly improve quality of life for residents. And the scale is just massive. By 2025, the number of IoT devices globally is projected to hit around 30 billion.
30 billion, wow.
Yeah, up from about 16.6 billion in 2023. So it's not just about efficiency, it's about making urban life more livable, more responsive.
That kind of real-time data flow sounds exactly like what autonomous vehicles would need to thrive. So the big question everyone asks, are we really going to be chauffeured everywhere by 2025?
Uh-huh. Well, probably not everywhere personally chauffeured just yet. Fully autonomous cars for widespread personal ownership, there are still development hurdles and significant regulatory questions to sort out.
Right.
But significant progress is being made in integrating levels of autonomy into, say, public transportation fleets and freight logistics. We're seeing more autonomous shuttles operating in controlled environments, like airports or campuses, and self-driving trucks are starting to handle long-haul highway routes.
Ah, so focused applications first.
Exactly. The aim across these sectors is clear. Reduce accidents, improve traffic flow by optimizing roads, maybe even decrease emissions through more efficient driving patterns. So while you might not have a fully self-driving car in your own garage next year, the shift towards greater automation in key transport sectors is definitely happening and advancing pretty rapidly.
Okay. Moving on, let's talk blockchain. Beyond all the cryptocurrency headlines, what's blockchain actually doing for us? What are its more practical, maybe less speculative uses?
That's a really important question, because the hype often overshadows the utility. Beyond digital currencies, blockchain is being adopted for its unique ability to provide, well, unparalleled transparency, enhanced security, and significantly reduce fraud.
How?
Because it's essentially a decentralized, immutable ledger. Think of it like a shared digital record book that once something is written, it can't be secretly changed. So we're seeing it used to track the origin and journey of goods in complex supply chains, ensuring ethical sourcing or food safety.
Okay, I see.
It's being explored for creating tamper-proof voting systems, for securely managing sensitive medical records, giving patients more control while ensuring data integrity. Fundamentally, it's about creating these trustworthy, unchangeable data records that build confidence and efficiency where trust might have been an issue before.
Right. Now, with all this interconnected tech, the IoT devices, the autonomous systems, AI making decisions, cybersecurity must be a massive growing concern. How is AI specifically helping us defend against these increasingly sophisticated threats?
Oh, AI is absolutely critical. It's moving cybersecurity way beyond just looking for known virus signatures. AI systems are being deployed now to automate really complex processes for detecting and responding to threats in real time.
So, faster reaction.
Much faster
Yep.
and smarter. AI can analyze vast amounts of network data, looking for subtle abnormal patterns that might indicate an attack. It can even predict potential threats before they fully materialize and automatically implement defenses. This capability is crucial because the sheer volume and complexity of cyber threats today just overwhelm human analysts. AI isn't just assisting anymore. In many ways, it's becoming the frontline defense.
So, if AI is so powerful, both as a tool and, frankly, its potential risk itself, what does this mean for building trust in the AI systems themselves? I know we saw mention of AI Trism.
Exactly. AI Trust Risk and Security Management, AI Trism, is becoming a really transformative trend. It's focused squarely on ensuring the reliable and responsible use of AI.
How does it do that?
By embedding transparency, rigorous risk assessment, and robust privacy safeguards throughout the entire life cycle of an AI system, from design and training to deployment and monitoring. It's about building confidence, especially as AI integrates more deeply into critical decision-making in areas like healthcare, finance, even the legal system. We need to ensure these systems are not just effective, but also fair, explainable, and secure. That's paramount for broad adoption and, frankly, public acceptance.
Makes sense. And finally, looking at the big picture, global impacts. What about sustainable technology? Is tech actually helping the planet? How is it driving environmental responsibility?
Sustainable technology is definitely pivotal now. It's moved from being a kind of niche concern to a core business strategy for many. It basically encompasses innovations that directly aim to reduce energy consumption, lower carbon emissions, and promote what's called the circular economy. Keeping resources in use for as long as possible, reducing waste.
So, practical examples.
Sure, companies are leveraging IoT sensors to optimize energy use in buildings and factories, deploying AI to manage waste streams more efficiently, improving recycling rates, using blockchain, like we discussed, for transparent supply chain tracking to ensure ethical and sustainable sourcing of materials.
Ah, interesting.
This isn't just about, corporate social responsibility checkboxes anymore. It's becoming a real competitive advantage as organizations demonstrate commitment to long-term ecological balance and attract environmentally conscious consumers and investors.
This has been an incredible overview of the tech landscape shaping up for 2025. So, okay, with all these amazing, sometimes maybe intimidating technologies emerging, What does this mean for you, listening right now, in your career? What specific skills should you be focusing on to stay relevant and, well, thrive?
Yeah, that's the crucial question, isn't it? It's clear that staying ahead, or at least keeping pace, is vital. The material we reviewed definitely highlights several key roles that aren't just trending, but are seeing significant demand as we head into 2025 and look beyond. First up, probably no surprise, the AI specialist. This role involves designing, programming, training these AI systems. If you're looking down this path, you'll need a strong foundation in machine learning, deep learning, neural networks, programming languages like Python, frameworks like TensorFlow. And critically, given how AI is being used, a strong grasp of AI ethics and responsible deployment is becoming absolutely essential.
And the pay reflects the demand, I imagine.
It does. Salaries typically range from about $85,000 up to $115,000 annually. It shows how valued these skills are. Then there's the highly specialized quantum computing engineer. These are the folks really at the cutting edge, developing the quantum algorithms and working on the quantum hardware itself.
That sounds intense.
It is. Essential skills include a deep understanding of quantum mechanics, obviously, familiarity with quantum programming languages like Qiskit or Cirq, advanced math, cryptography, and just exceptional problem-solving skills. Salaries here are significantly higher, reflecting the scarcity. Think $127,500 to $147,000 per year.
Wow. Okay.
We also see continued high demand for 5G network engineers. These are the people installing, maintaining, optimizing the actual 5G networks that everything else relies on. Key skills: wireless communication protocols, network security, RF engineering, cloud computing, and definitely understanding IoT integration, since 5G enables so much of it. Salaries there are roughly in the $75,000 to $95,000 range. Still very solid.
Underpins everything else, really.
Exactly. And tying into the Internet of Things we discussed, the IoT solutions architect, this person designs and implements the whole IoT system for smart cities, industrial automation, smart homes. Requires expertise in embedded systems, IoT security, cloud platforms, sensor integration, languages like Python. They're making that connected vision a reality. Salaries typically between $80,000 and $100,000 annually.
It's fascinating. So many of these roles need not just that deep tech skill, but also analytical thinking, problem solving, and like you said, increasingly understanding the ethical side. But the good news, right, is even if you don't have a traditional computer science degree, the material suggests that with the right focused training, maybe certifications, you can actually pivot into these fields.
Indeed, absolutely.
Yeah.
For example, mastering critical skills like ethical hacking or risk management, which are vital for securing AI systems and all those billions of IoT devices that can often be achieved through dedicated, focused programs. The Cybersecurity Expert Master's Program mentioned in the sources is a good example of how targeted, hands-on training can give people really highly sought-after skills. The demand for these capabilities is just immense, and it cuts across almost every single industry.
So wrapping this up, what does this all mean for you looking ahead?
Well, it means 2025 is shaping up to be a year of just incredible technological acceleration. And staying informed, understanding these shifts, adapting your skills, that's really your superpower right now. Absolutely. And remember, knowledge is, most valuable when it's understood and actually applied. By focusing on these emerging technologies, the associated skills we talked about, you can not only future-proof your career, but also position yourself to contribute meaningfully to this rapidly evolving, tech-driven world we're all navigating together.
And maybe here's a final thought for you to mull over as we finish today. As AI and these other transformative technologies get woven more deeply into our daily lives, how we work, learn, how our cities run, how will we as a society strike that balance? The balance between the incredible convenience and efficiency they offer and the fundamental need for human connection, ethical oversight, and maybe even the ongoing evolution of our own unique human capabilities. What new opportunities might actually arise from finding that balance? We really hope this deep dive has given you a valuable head start in navigating the exciting, sometimes maybe a little daunting, landscape of 2025. And before we go, just a final reminder that this deep dive is brought to you by StoneFly. And hey, for our listeners looking for a really powerful and secure storage solution, make sure to check out StoneFly's 100 TB immutable and air-gapped SSO NAS. It's currently available for $8,995. You can find out more at stonefly.com. We'll see you on the next deep dive.